Students, another lecture about chapter number 25, physics for scientists and engineer. So this is the chapter name is electric current and resistance. So the topic is electric current. So let me define the what is current means. Current means flow of charge, flow of charge, flow of charge per unit time, mean how much charge flows in unit time is called electric current. So current is defined as electric current is denoted by I, that is equal to flow of charge del Q divided by time del T. So I stands for the current, electric current is I, and Q is the charges, how much charge or charges flows in T denotes for the time, how charge divided by time is called electric current. Okay, now the average value of the current is denoted by average value is del Q over del T, del Q over del T. So this is the how much the coulomb charge changes in the and how many times. So change of del Q mean the change, total change in how much coulomb charges changes and how much time. For example, if say we say that 100 coulomb flows in 20 seconds, so that the current is 5 coulomb per second. Okay, now another thing is the current can also be average and current can also be the instantaneous. So what is difference between instantaneous? So current instantaneous is the rate of flow of charge can be replaced with the dq over dt, so dq means that we take the small change in time, small change in current, small change in charges dq divided by dt. We integrate the charge with respect to time, we derivate the charge with respect to time, dq over dt is the instantaneous. It will give us the small change in current for a specific time. Instantaneous current mean the current for a small time, current flow in very small interval, in very smaller interval. So we say that the current flows is 0.01 second. So how much current flows in 0.01 second? It's very small time. So when the current flows for a very small time, so we say that this is the instantaneous current. And average current is the mean the total charges flows in large time. The time is large in the average value. Okay. So but basically main thing is that the current is equal to rate of flow of charge dq over del q over del t. Okay. Now we have to draw the diagram in order to understand how the current flows. For example, we have a bulb and we connect this bulb with the battery. Battery is in the previous lesson we discussed that battery provides a potential difference. So this is positive terminal of the battery, that is at the higher potential. So for example, this point A is A and other one is a negative terminal, so this is point B. So A point and B point has the potential difference. There is a potential difference between A and B, so that the charges move from high potential towards the low potential. So the positive charges moves towards the plus charges moves from the positive terminal towards the negative, high potential towards the negative potential. So the direction of conventional current is those current that the current that flows from positive terminal towards the negative terminal. So that the current flows from positive terminal towards the negative terminal. So here is the diagram. So we connect electric bulb, and when we connect electric bulb and with the battery, so the current starts flowing from positive terminals towards the negative, so that the bulb will glow when we connect bulb with the battery. So simple is that. Okay, now we move on and we discuss the unit of current. So the unit of current is simple ampere. This is the name of a scientist who discovered current. So ampere is 1 ampere is equal to 1 coulomb per second. We can derive this unit from the I is equal to dq over dt. So the current is in ampere, so Q is in coulomb and time is in second. So the 1 ampere is equal to 1 coulomb per second. And there are some smaller and bigger units, just like 1 milliampere is 10 raised to the power minus 3 ampere, 1 microampere is 10 raised to the power minus 6 ampere, 6 10 power minus 6 ampere. Okay. For example, another thing in the last paragraph that we discussed here. So for example, there is a difference between open and closed circuit. This is the closed circuit that we connect in the above, because all terminals or wires are connected. So for example, if we open these two terminals, any two terminals, now we open this one. So this is positive terminal, this is negative, so this is open. So when we open, mean that we disconnect the wires so that the charges will not able to move, current will not flow. So the current, total current in the bulb will become 0, no current flows through the bulb. So if we open circuit, so that when the circuit is open, so the no current flows through the bulb. Okay, thank you. So this is all about the electric current. Electric current is mean that charges flows in unit time. How much coulomb charge flows in time t is called electric current. We just divide the coulomb charge divided by how much time, so we get the current. So the current, unit of current is ampere, and we discussed in detail. Okay, thank you.